first day, we'll start gently with the probe. That's the simplest vehicle you will encounter. The landing sequence is entirely automated. You can observe the fall via the fixed camera plugged at the front of the probe.
We're above the area, preparing for the drop. Ready for the drop on your mark.
You can switch to the external camera with the camera key to observe the automatic landing thrusters. Press the camera key several times to look between the different cameras. Great, that was a hassle-free landing. Now, before we start, there's some information to assimilate to remotely control the vehicle. Let's go through them one by one, starting with location info at the bottom left corner. Each element of the interface can be minimized and maximized by clicking the Minimize/Maximize button with the mouse cursor. Use the right mouse button to show and hide the cursor, then click on the Maximize button of the location panel to reveal its info. This panel shows local and earth time, the date, and even temperature and air pressure when the vehicle is equipped with an environmental monitoring station. The next one is the mission panel at the top left corner. You can see here the vehicle's name, the SOLs, for Solar Day on Mars, since the start of the mission, and the distance traveled by the vehicle. Let's go through the 4 drop-down tabs one by one. The navigation tab filters the waypoints displayed on your interface which are in relation to the mission's tasks. It also provides a live feed satellite view with vehicle tracking. The Mission tab provides detailed information about the current mission and its objectives. Click on the Tasks arrow to switch to an overview of all the unachieved tasks assigned to the current mission. You can see here that only one task is scheduled. We'll get to it later. You will have noticed that an Explore task has been automatically completed at the probe's landing. The Explore task is always performed at each mission start. It confirms a successful vehicle landing. The Log tab logs events of the mission and vehicle. The Connect tab shows a list of all active vehicles in the same area and allows you to connect and take control of them directly. Now, close the current tab so we can continue. The vehicle's standard controls panel is located at the bottom of the interface. The basic probe has no controllable parts. We'll go through the vehicle controls later. The probe consumes very little power to remain active, but will run out eventually. Check the power panel in the bottom right. Currently available power is displayed as a blue bar at the top of the panel. Charge and drain rate fields indicate immediate charge and drain values in watt-hours. The bar at the bottom indicates the amount of auxiliary power in chemical batteries, which serves to refill available power. The basic probe has a single camera at its bottom and can have one single measuring instrument. The panel at the top right corner is divided into Cameras and Instruments tabs. Open the Instruments tab. First is a list of all the instruments installed on the vehicle. Our probe only embarks on an environmental analysis station. Clicking on an instrument will highlight it. Highlighted instruments have their status and information displayed below the list along with a button to operate them. Double-clicking on the instrument will select it and open the instrument HUD. Now select the EAS. The instrument HUD that's just superimposed on the interface shows complementary information, including controls to operate the current instrument. You can switch between 3 HUD modes, Instrument, Standard, and Camera, with the corresponding icon at the top of the screen, or cycle them with the HUD key. Switch to the Standard HUD and we can finally start with the mission. Basic probe missions are the simplest and cheapest you can do. Probes are mostly used for exploration only, but they can also monitor or analyze the nearby atmosphere. This is exactly the task you are assigned now. You can have a look at it in the task list of the Mission tab at the top left panel. To analyze the atmosphere, we will use EAS embedded in our probe. All environment instruments are usable without requiring any special position or distance to the target. Note that moving an instrument while it is sampling will compromise the sample process and you will have to start over. Congratulations! You have brilliantly operated the probe. This was just an appetizer. Now let's move on to the small lander.
Lander is ready for the drop.
Waiting for your mark, over.
Copy that. Proceed with the drop. Out.
All right, landing phase initiated. Take this occasion to study the specific flight mode HUD. The landing target is clearly visible as a green circle in the middle of the screen. The yellow cross is the velocity vector. It indicates the vehicle's current speed and direction. Now at the bottom right, fuel consumption is higher because of Earth gravity but still in norm. Descent speed at top right corner is about 5 meters per second. Everything looks fine. Once landed, the lander switches to standard mode, displaying a standard HUD. As you can see, all vehicles share the same on-screen interface. Let's now have a look at the standard controls panel. It consists of primary and secondary controls. Their purpose is to control a specific element embarked on the vehicle. Scroll through the elements of this lander by clicking on the small left and right buttons of the primary and secondary interface. A mouse icon indicates that the selected element can also be controlled with the mouse. You can also scroll through the list of primary items with the switch keys. Then use the movement keys, or the dedicated 4 arrows primary interface to control the selected primary item. For secondary controls, you can also use the switch keys to scroll through the list of secondary items. Then, use the movement keys, or the dedicated 4 arrows secondary interface to control the selected secondary item. For a summary of the controls, open the Options menu, go to the Key Bindings tab, and select the Vehicle section. The small lander possesses 2 robotic vertical arms that can carry a wide range of instruments. First, select the right arm by scrolling to the right robotic vertical arm with the switch keys, or by clicking on the small left and right buttons with the mouse. Good! Now extend it by holding the movement keys, or by clicking with the mouse on the 2 big up and down arrows of the standard controls panel to move the attached instrument close to the ground. Good. The instrument is now in range for analysis. Speaking of analysis, a new mission has been assigned to the lander. Select the valid instrument required for the next analyzed task. This information can be found in the Tasks of the Mission tab in the top left panel. Then, select the instrument from the Instruments panel in the top right. Unlike environment instruments, active instruments like the Alpha Particle X-ray Spectrometer, or APXS, require an exact positioning in relation to their target. They are mostly mounted on a robotic arm for its ability to adjust their position and distance to the target. APXS irradiates a surface up to 100 millimeters away to discover elements contained in the analyzed area. Start the analysis when ready. Note that moving an instrument while it's sampling will compromise the sample process and you'd have to start over. Once irradiating is complete, the sample analysis follows. When the analysis is over, you can monitor the mission's completion in the Mission tab. And voila! You've done a great job. You've been assigned a new task. Repeat what you just learned to perform it. Assess the task, then select and make the proper use of the instrument. Good. Now you know how to use all the active instruments.
Hotel Actual to the control room. The site is clear. I repeat, the site is clear. Over. Copy that, Hotel Actual. Out.
All vehicles, with the exception of the basic probe we've already been through, can move one way or another. We've got another mission for you in this area. Open your map with the map key. On the map, you can see your position, and all available missions are marked with the pin icon. The nearest, and in our case, the only mission, is located to the right of your position. While the mission is selected, click on Humidity, the name of your lander, and press the green Assign Vehicle button. Leave the map once the vehicle has been assigned to the mission. Lander thrusters serve not only for landing, but also for moving between nearby tasks or missions. To switch to flight mode, hold the radial menu key and use the mouse to click on Flight to Waypoint in the right box. In flight mode, HUD elements are different and only the descent camera, mounted at the bottom of the vehicle, is online. Since we are testing on Earth, fuel consumption is greatly increased because of our higher gravity. Flying manually is possible, but the automatic system consumes less fuel, and we cannot afford to run out. This mission consists of photo tasks, so we'll use the Camera HUD and Cameras tab of the Instruments panel. To get pictures, we need you to move the science platform that has cameras 2 and 3 mounted on it. Depending on the distance between photo markers, you need to choose different cameras with various field of views. Now, take some shots of the launcher platform. Those are some nice shots. All right, that wraps up the lander training. Oh, before we move on, did you know you can switch among multiple vehicles when they are in the same area? Open the Connect tab of the top left panel. You can see the probe we used before in the vehicle list. Click on the probe line and press select to switch to that vehicle. Good job! This is how you switch to other vehicles located in the same area. Alright, that's everything you need to know about the landers. Next up is the rover. Welcome to the rover part of your training. Rovers are mobile vehicles designed for the last years on Mars, while completing many different tasks throughout their lifespan. In that regard, they can be fitted with foldable solar arrays. The solar panels are folded in order to save space during landing. They should be deployed as soon as the vehicle is safely on the ground. Select the Robotics solar panels in the Standard Controls panel and unfold them. Once fully deployed, you can check the power input in the Power Level panel. Depending on the conditions, a vehicle can obtain more energy from the sun than it consumes. Smaller or larger solar panels can be installed, depending on the vehicle's size, the exception being the probe. Keep deploying the panels to their final position. That's it. Now larger vehicles like rovers can be piloted thanks to their 6-wheel driving system. We'll try it right now with the new Explore task. Exploration complete. Now, keep moving to the new Analyze task that has just been assigned. It consists of a stone to analyze with the APXS. Switching to the instrument HUD will help identify the sampling area. Rovers possess specific robotic arms that unfold slowly into an L shape with a 180-degree rotation. Its head can hold several instruments, fully rotates 360 degrees sideways, and turns 180 degrees down. Position the rover with the robotic arm toward and close to the sampling area and unstow it. You can also use the robotic arm head to fine-tune the position and distance of the installed instruments. Remember, the instrument HUD indicates the exact distance between the selected instrument and the surface in front of it. Once the irradiating is done, stow the arm back so it won't break. Great. That is how you control the robotic arm and its head. Next, we'll use the last type of instrument, which are passive instruments. Passive instruments require no action on the control side, but as environmental instruments, they require you to be stationary in the task area. Drive into the next task area and stop there to complete the passive instrument analysis task. Note that passive instruments are not checking surroundings constantly, but in short intervals to save energy. Completing their task may take several seconds. Good job. Final part to go through is the top-mounted mast. This mast has only 2 low-powered slots for cameras, where the advanced mast has 3 slots and can be fitted with a chemistry laser spectrometer on top. The mast can rotate nearly 360 degrees sideways and 160 degrees up and down. The last task we have for you is to take a close-up colored picture of the probe. There is a multi-zoom camera mounted on the mast, so you can look around using the movement keys, while the mast system is selected in the standard controls panel and the zoom on camera is selected in the cameras tab. If necessary, you can drive closer to take the picture or use the zoom function with the mouse or the plus and minus buttons of the camera HUD. You can use the mouse to move the mast if it's selected above the correct control panel. Nice work. This concludes everything we can teach you here. Let's move into the simulator to try out the Zero-G probe.
Welcome to the Zero-G probe simulation program. Program settings, basic vehicle controls and extreme environmental conditions.
First, the controls. The Zero-G probe can move and rotate in all directions. Linear thrusters control the probe's movements in all 6 directions. Select linear thrusters and use the movement keys to move forward, backward, left, and right. Use the up and down keys to move up and down. Try out the linear movement. Attitude thrusters control the probe's rotation. Select attitude thrusters and use the movement keys to roll forward, backward, and rotate left and right. Use the up and down keys to roll left and right. Try it out and move around a little for a few seconds. That's enough. You've got the hang of it. Now let's try that without the automatic assistance systems. To turn them off, hold the radial menu key and use the mouse cursor to click Cancel Kill Rotation and Cancel Kill Translation buttons. Now, move around for a few seconds, bearing in mind that if you rotate the probe too fast in any axis, it will eventually break. With assists off, you have to stop the vehicle yourself, including the rotation. Okay, stop the vehicle now. Use the Kill Translation button in the radial menu if necessary. The third and last assist is gravity vector alignment. This is applicable only in places with a detectable gravitational field. Turn it on through the radial menu. The probe will set its default rotation with the bottom towards the gravity and will always reorient that way. Try it out by rotating the probe a little. We're all set with the controls. Let's try it out with a task. Complete the assigned tasks with a combined knowledge of previous training courses. Good work. Now for the last part.
Simulating environmental conditions. Environmental conditions have been set to maximum.
If you look around the probe, you'll see meteorites hitting the surface all over the place. During this simulation, they will never hit you, so don't worry. But in reality, even a single meteorite is enough to destroy the probe. Plan the missions carefully, and always try to avoid sending missions to locations with bad environmental conditions. Okay, that is all you can learn here. Let's move on to the real thing.